Welcome to the third lecture in the module 3 in the subject hydrology and water resources. So by now we have learned about hydrological cycle, and then we started the small parts of hydrological cycle. So we have by now we have completed evaporation, then we started evapotranspiration, okay, then we went to the abstraction process, okay. So what was the abstraction process? It is a process in which earth takes water from the atmosphere, okay. Whatever water is poured by the precipitation, some of the water is absorbed by the ground or earth's surface. So that amount of water that is taken by the earth is called abstracted water, okay. In that sequence we will move ahead, okay. So for abstraction, the very important process that we have is called infiltration, okay. So today's topic will be infiltration. So what do you mean by infiltration, okay? So let's see it like this, that if there is some ground, okay, this is let's say this is some ground surface, and there is some precipitation, okay, some water, okay, comes to the surface, then what will happen? This water will be divided in two types or two categories, okay, two major categories I should say. What will happen? Some of the water will start moving in this way, okay. If the slope of the ground is like this, so this water will start flowing like this, okay. This is your precipitation, and the water which started flowing like this, okay, this is called, this water will finally meet to the river, okay. This final water will finally meet to the river or some stream, okay. So this water is called your runoff, okay. And what will happen, out of the total water which is coming from the atmosphere, some of the water will be absorbed by the ground, okay. Some water will go inside the earth, okay. So this water which is going inside the earth's surface or ground is called infiltrated water, okay. This is called infiltrated water, and this process of water going inside the ground is called infiltration process, okay. So if you see here, the same point has been explained in this so the same point is explained from the first bullet point. Now what is your second bullet point says is, it says that infiltration is a way or is a process which finally leads to the groundwater recharge. How water is stored by the earth or ground, okay, So that recharging or filling of the voids of the soil is done by the process of infiltration. Okay, it is very easy to understand. So after that we have two other terms. One is called infiltration rate and another one is called infiltration capacity. So what is infiltration rate? So if you see, the water which is entering the earth will enter with some velocity. Okay? Some water will enter the earth with some velocity. Okay? That rate of water entering the ground is nothing but your infiltration rate. Okay? And what are infiltration capacities? When these rates reaches to a maximum rate, okay, these rates are changing. Okay, so when you pour water, it will enter the earth with some velocity. Then after some time, that velocity will change. Okay, so the upper limit, okay, the upper limit of those rate or the maximum value of the rate is called infiltration capacity. Okay, so infiltration rates are any velocity of water, okay, at any time, and infiltration capacities are the maximum values of those rates. So this is the basic philosophy. So now how do you measure these infiltration, okay, or these infiltration rates? So we have devices, okay, so those devices are called infiltrometer. Okay, so you can measure infiltration rates by the help of infiltrometers. Now how these rates changes, okay, so or how these rates are defined. Okay, so for this we have a topic that's called variation of infiltration rate. This theory or this total final mathematical formula was given by a mathematician that is called Horton. Okay, so Horton gave this formula. So what this formula says, that if you want to check the rate of infiltration at any time, okay, so the rate will vary in this manner. Okay, the change of the rate will be following a particular pattern. That pattern have a formula like this. So you can see this is a exponential curve. Okay, so the change of the rate, okay, of infiltration rate is basically your exponential curve. Okay, now what is this FT? FT is infiltration rate at any time. Okay, at any time. What is FF? FF is called your final infiltration rate. What is Fi? Fi is called your initial infiltration rate. And FF, I have already discussed that. Then T is the time with which you're trying to study. Okay, T is the time. K is a constant. That constant depends on the type of soil, okay, the permeability, etc., the various property of the soil and the ground. So also the if there is some vegetation, because that also affects the properties of the soil. So this is a constant. So if you wish to draw a curve for this. So let's try to draw. Okay. So the curve is like this. Ft is equal to Ff plus Fi minus Ff e to the power minus k dot t. Okay, so let's try to draw this curve. So let us say this is your Cartesian coordinates. Okay. Now on y-axis it is infiltration rates. So on y-axis it is Ft, or you call it as infiltration rates, and on x-axis it is time. So you can write time. Now if you realize the fact that time cannot be negative, okay? Time cannot be negative, that means time should always be, okay, positive, or it can be zero. So that means that there is no logic of this quadrant and this quadrant, because after this point, time t is equal to 0, the curve cannot be drawn, okay, because time cannot be negative. So I will remove this part. Okay, we don't require curve on these quadrants. Okay, so it should be on first quadrant and fourth quadrant. Now I will draw the curve step by step. So first let me draw the curve for y is equal to e to the power minus t. Okay, so if you draw this curve at time t is equal to 0, if you put t is equal to 0, what will you get? Y's value. Okay, so if you realize this, it is nothing but e to the power t. It will be around 1. That means at time t is equal to 0, the curve should intersect at 1. So this must be its initial point, okay, where it is a 1. Then if you put time is equal to infinity, you will get y is equal to e to the power infinity, which is nothing but 0. So at infinite time, the curve will end at some 0, which is basically your limiting value, okay, because you cannot define the infinity. So it should closely go to like this. Okay, it is asymptotic to the x-axis. So this is a curve for e to the power minus t, but you want minus kt. Okay, so if you see that if you multiply by some constant, the value has to decrease. Okay, so at any point the value will decrease. So if you draw another curve, it will be like this. This curve, this is your e to the power minus kt curve. Then you have to multiply it by some constant. This Fi is initial value of infiltration rate and Ff is final rate. Okay, so this has to be multiplied. Okay, so if you multiply, how will it be? It will rise to some value. So it will rise by some value. So if you draw the curve, it will be again like this. What is this curve? Fi minus ff e to the power minus kt. Then what you want to add some value, you want to add some constant to this curve. So when you add some constant, it will rise to this one. Okay. So let me change the color. Okay, so you should see that it will be like this. It will be like this. This is your final curve. Okay. So if you see that, what is this? This is your this is your initial rate of infiltration. So this point is nothing but your f initial rate, and the curve is going constantly towards 0, but not 0 at infinite time. So not 0, because infinity cannot be described. So this final value, if you could watch this, so this final value is nothing but your f. Okay, so this is the final curve. So let me remove all other things. So this is your final curve. So if you see this curve closely, then you will realize that as time increases, the value of f is constantly decreasing. Okay, the curve is a decreasing curve, which also means that infiltration rates will decrease slowly, okay, in a exponential function. तो अगर आप सेम चीज को रियलाइज करना चाहते हैं या फील करना चाहते हैं, तो आप क्या करिए, आप एक ग्राउंड लीजिए, उस पर आप पानी गिराने की कोशिश करिए. तो आप शुरुआत में देखेंगे कि क्या होगा, पानी अर्थ जो है काफी उस पानी, जितना भी आप पानी डाल रहे हैं उसको एब्सॉर्ब करता जा रहा है. बट अगर आप उसी रेट को कॉन्स्टेंटली डालते रहेंगे, ओके, आप कॉन्स्टेंटली पानी डालते रहेंगे, तो कुछ देर बाद पानी क्या होगा, अर्थ एब्सॉर्ब करना बंद कर देगा और क्या होगा, वो सरफेस पे फ्लो होने लगेगा. बिकॉज कि कुछ टाइम बाद जो इन्फिल्ट्रेशन रेट है वो क्या हो गया, कम हो गया. कम होने की वजह से पूरा पानी अब अंदर इन्फिल्ट्रेट नहीं कर रहा है, वो सरफेस पे फ्लो कर रहा है. सो दैट इज बेसिकली योर फंक्शन. तो उतने जो टाइम के बीच में किस तरीके से वो इन्फिल्ट्रेशन चेंज हो रहा है, then it is given by this function. Okay, so Horton's has given this one, and Horton's have contributed a lot in the field of hydrology. So Horton's is also called as father of hydrology. Okay, so let's move ahead. Now, if you realize that infiltration rates are constantly changing, okay, हर टाइम पे infiltration का rate क्या होता है, अलग होता है. So it is basically a continuous function. But for us as a civil engineer, we are not concerned about that change. हमें उससे ज़्यादा फर्क पड़ता नहीं. हमारा टारगेट क्या है? डैम बनाना, रिजर्वायर बनाना, उसमें वाटर की कैपेसिटी कैलकुलेट करना या ये सब डिजाइन करना। तो हमारे लिए वो बीच का चेंज मायने नहीं रखता है। हमारे लिए मायने क्या रखता है? मैक्सिमम रेट्स या कैपेसिटीज। ओके, सो फॉर नाउ what we will do, we will not talk about infiltration rates, we will talk about infiltration capacities. Okay, and now we will assume that infiltration do not follows the changing attitude, or it do not follow that changing function. We will say that earth will follow a constant infiltration rate. Why we are doing this? Because we want to design something based on some safety factors. So we are not worried about that change. We just want to talk about the maximum values. So when you talk about the maximum values, so how these values can be quantified? Okay, so let's say. So before coming to that, this is a graph, basically a histogram, and we have a term that is called hydrograph. So hydrographs are basically histogram, and on x-axis there is time, and on y-axis it is a rainfall intensity. Okay? Rainfall intensity means the change or the value of rainfall which is occurring with respect to time. Okay? So if you could see the unit centimeter per hour, what is the velocity of rainfall that is coming to the earth's surface. So this histogram is referred as hydrograph. So now we are coming to that point, that infiltration capacities. So those capacities are also called as infiltration indices or index. So first kind of index is W index, and second index is phi index. So what are these index? These are nothing but infiltration capacities. Okay, the values of infiltration rate which have some limiting value or maximum value. Okay, so what is W index? So W index is the average rate of infiltration. Infiltration is constantly changing, so we are saying that we don't want a changing value, we want a average value, that we are calling it as W index. Okay, average rate. Then we have another index, phi index. So the phi index is the maximum rate of infiltration. Okay, average rate of infiltration and maximum rate of infiltration. So how these values are calculated? Okay, so this much is written, but I would like you to come to this graph. Okay, so this is nothing but your hydrograph. Okay, so if you see that this is the rate of rainfall or rainfall intensity. आप इस तरह इमेजिन करिए, अगर 5 mm रेनफॉल हर घंटे में गिर रही है, ओके, और अर्थ क्या करेगा, उसको जैसे वो अर्थ पे गिरेगा, some of the water will be taken inside the earth and some of the water will flow. But if this earth have infiltration capacity or rate, okay, इसकी कैपेसिटी है लेट अस से 7, और अगर 5 सेंटीमीटर पर आवर का पानी यहाँ पे गिरेगा तो क्या होगा, पूरा वाटर विल बी गोइंग इनसाइड द अर्थ. ओके, इफ 6 सेंटीमीटर पर आवर से रेनफॉल होगा और इसकी कैपेसिटी अभी भी 7 है तो क्या होगा, all the water will go inside the earth. If 7 centimeter per hour से रेनफॉल होगा, all the water will go inside the earth. But if 7 से ज्यादा हो, 8 centimeter per hour हो, तो what will happen? Some of the water will be going inside the earth, but remaining water will come as runoff. Okay. So this is the ideology that you have to identify infiltration rate. कि infiltration rate important point क्या है कि अगर इसकी infiltration capacity से ज्यादा अगर रेनफॉल होता है, रेनफॉल इंटेंसिटी ज्यादा होता है, ओके, इसकी कैपेसिटी से रेनफॉल इंटेंसिटी ज्यादा है, तो क्या होगा? वाटर विल फ्लो, रन ऑफ विल बी क्रिएटेड. लेकिन अगर सारा पानी क्या होगा? अंदर जा रहा है, दैट मीन्स दैट द इनफिल्ट्रेशन कैपेसिटी इज ग्रेटर देन द रेनफॉल इंटेंसिटी. So assuming that you have got the point, so if you see this, okay, so these are rainfall intensities and these are times, 1 hour, 2 hour, 3 hour, 4 hour, 5 hour, 6 hour. So if you see that, if you draw the intensity for that some time in terms of histogram, so if infiltration capacity or infiltration rate is like this, ये maximum rate of infiltration अगर है, अर्थ का infiltration rate क्या है, उसकी maximum value ये है, तो अगर क्या होगा? आपकी रेनफॉल इस वैल्यू से क्या होगी? अगर ज्यादा होगी तो क्या होगा? रन ऑफ क्रिएट होगा. अगर infiltration rate से ज्यादा तेजी, ज्यादा इंटेंसिटी से वाटर आ रहा है, तो क्या होगा? Some water will flow. Okay, that flow is called your runoff. So if you see, observe this, these blue lines which are greater than your phi index are nothing but your runoff value. Okay, whereas this yellow color, okay, these intensities are lesser than your infiltration capacity. So all this water will go inside the earth. Okay, if you understand this point, you can also calculate this values. Okay, how to calculate this? So very simple. You draw this graph. Okay, then you take these areas. So what this area will give? Centimeter per hour multiplied by hour is centimeter. So which is nothing but rainfall or unit of water or precipitation. So the areas, these areas are the areas which is giving the amount of water which is going inside the earth, okay, which is your infiltration. So this is infiltrated water divided by time, okay. So this will give you what? Infiltration capacities. Now when it will be W index and when it will be phi index, so again you can observe here. So if you want to calculate the average rate of infiltration, what you have to do, you have to take all the rainfall which is creating runoff and which is not creating runoff, like A1, like this one, okay, this whole one, and this is not. This block is not producing any runoff. Why? Because it is lesser than infiltration capacity of earth, so all the water will go inside the earth. Whereas you see this one, the amount of rainfall intensity is 23. So what will happen? It is greater than this. So what will happen? Some water will go inside the earth, some water will be flowing as a runoff. So if you consider all such rainfall intensities, then it will be your average value. But if you are interested in calculating the maximum rate, okay, not average rate, you want to calculate the maximum rate, what you have to do, you have to take only those areas okay, only those areas which are creating or generating runoff. Okay? So you have to take this one, and this one, because these three values are creating your runoff. runoff क्रिएट हो रहा है, तभी आप पता लगा सकते हैं कि ये मैक्सिमम वैल्यू है या नहीं है. Okay? So if you observe here, 5 index have A2, A3 and A4. A2, A3, A4. These three blocks are creating runoff. That is why we have taken. Similarly, we have taken time for these A2, A3 and A4. Okay. So when you do this division, you can get your maximum rate of W index or phi index. Now let's try to solve one question, that if you understood this or not. So you can read the question, and it says that a storm happens and which produces a precipitation of 10 centimeter, and runoff value is 5.8 centimeter, and this details are given for drawing your hydrograph or histogram. So now if you could observe here, that one more thing I left is you can calculate W index like P for precipitation, Q for runoff. Okay, so if some water is coming like this on the earth's surface and some water is flowing, so if you take the difference of them, what will you get? You will get the water that is going inside the earth, or that is your infiltrated water. Okay, so it is the same thing. So let's try to solve this. So what it says, it says time and rainfall intensity, then 1, 0.4, 2, 0.9, 3, 1.5, 4, 2.3, 5, 6, 7 and 8. So if you draw the hydrograph for this, this is nothing but rainfall intensity. So from 0 to 1, okay, what is the value of intensity? 0.4. So draw it. This is 0.4. Then from 1 to 2, it is 0.9. Let's draw this. This value is nothing but, let me write here, 0.9. Then from 2 to 3, it is 1.5. Okay, so let's draw it. This value is 1.5. Then 2.3. Let's draw the fourth one. This value is 2.3. Then for fifth, it is 1.8. Let's draw for this value is 1.8. Then for 6th, it is like this. The value is 1.6. For 7th, the value is 1. Sorry, it's like this 1. And last value is 0.5. So this is your histogram or hydrograph. Now you want to calculate the value of phi index. Okay, you want to calculate the maximum value. So how will you calculate? So let's do one thing. Let's calculate the value of W index. Okay. So let's calculate the average value. So if you see the formula, it is P minus Q minus delta L divided by total time. If you see this formula, okay. So what is the value of precipitation we have? So go back to your question. So total precipitation is 10 centimeter. Then what is the value of runoff? So if you see the question, it is 5.8. And what is the value of initial loss? So nothing is mentioned in the question. That means its value is 0. So 0. Then what is the time? What is the total time? So you see here, it is 8 hours. So if you calculate this, you will get 10 minus 5.8 divided by 8. The value comes out to be 0.525 centimeter per hour. So this is the value of W index, the average value. This is average value. So you can put the value in your hydrograph. Okay. How much was the value? 0.525. So it's like this. This rate was 0.525. Now if you observe here that you have taken this area, this area, this area, this area, you have taken everything, okay, and this value 0.525 is calculated based on this one and this one, and these values are not producing runoff. So what you have to do, you have to remove these values. You have to remove these values. Okay. Why? Because they are not producing runoff. Okay. So you have to remodify your value of index, because that is the average value. It is not a maximum value. It is not the phi index. So what you have to do, you have to calculate the different indexes. So let's do the trial. Okay, you understood that 0.525 is not the maximum value. Why it is not the maximum value? Because these and these were included in its calculation. Okay, so this is not the maximum value. So what you have to do, you have to calculate the infiltration rate again. So in some book they don't calculate a W index. They simply assume some value, okay, like 0.3, 0.28. Then they start these trials. So for some student it might be difficult to assume the value. So instead of assuming, you can start with W index. Now to calculate this, what you have to do, you have to calculate the areas. But which areas? The areas which are giving or generating runoff. So what are the areas? This area, this area, this area, this area, this area, and this area. These are the areas. So you have to remove the first value and the last value. So what you can do is, so I will remove the first one, 0.9 plus 1.5 plus 2.3 plus 1.8 plus 1.6 plus 1 and divided by, you have removed two areas, so you have to remove their corresponding time. So two areas have two time, so you just have to remove 2 hours. So then you can calculate precipitation, and you have to remove the runoff. So the value of runoff is 5.8. Then you can calculate the value. So it comes out as 0.55 centimeter per hour. Okay, what I have did, I have removed 0.4 and 0.5. I have removed these two parts. So you get this value. So you have to check whether 0.55 is maximum value or not. Okay, so how will you check? You have to come back to your hydrograph and you have to draw it again. You have to draw the value. It is like this, 0.55 centimeter per hour. Okay, so now you see that this line is calculated, okay, based on the 1, 2, 3, 4 and 5 and 6, not this one, not this one. And this line do not have any block which is not contributing to the runoff. Okay, so that also means that this value of infiltration is the maximum value, okay, because all are contributing to runoff. सारी values, सारे blocks क्या कर रहे हैं, runoff generate कर रहे हैं. इसका runoff तो तभी generate होगा जब precipitation और infiltration को आप compare करें. तो precipitation जो आ रहा है, ये जो infiltration capacity है, तो infiltration capacity कम हो, इस precipitation से तभी water flow करेगा और runoff generate होगा. Okay, that also means that this is the maximum value. Okay, so it is good that in our first trial itself we are getting this 0.55, which is a maximum value. That also means that the value of phi index is also 0.55 centimeter per hour. Now some of you must be confused with this, like here I was doing like this, here I was doing like this, but it is both the calculation are same. Okay, if you add all these values, okay, if you add all these values, it will be nothing but Okay, if you add all this value, it is nothing but your total precipitation. The sum of all these value will be 10. So you don't have to worry about that, why I did this in half and like this in another half. You can do it that way also to verify yourself. But to understand that in one question itself, I am doing this in two different formats so that you can verify it. So this is how we calculate the value of infiltration index. So I hope you might have learned something from it. So this is all for today's lecture. We will meet in the next segment. Thank you very much.